Okay, today we're going to talk a little bit more about the system of complex numbers. And the system of complex numbers that we call C as opposed to R for the real numbers consists of all the expressions in the form A plus BI that have the following properties. A and B are real numbers, and I, of course, is the square root of -1. And I squared equals -1. Now the nice thing is you can use addition and multiplication as if A plus BI were a polynomial. And we'll see why, and we'll see some of the properties that apply in math to this, so that you can see that how you work with these really is a lot like how you work with real numbers. Okay, so to do this we want to talk about properties of mathematics. The associative property for addition and multiplication. Remember, associative property groups things differently. So if we have B plus C and then add A, it's the same as having A plus B and then adding C. And the same thing applies with multiplication. So if we multiply two things together and multiply then a third, it's the same as multiplying the first two together, A and B, and then multiplying C, if that makes sense. So it's really a grouping thing, and it says it doesn't matter. The associative property of addition and multiplication says grouping does not matter, it does not change your outcome. The commutative property says order doesn't matter. We can add things in different orders, we can multiply things in different orders, and that's why when I say, yes, switching the order of these things is okay by the commutative property, this is the property I'm speaking of. And finally, the distributive property also applies. So if I have some number times the sum of two other things, I can distribute that number A to B and C. And so I get AB plus AC. So let's create some examples of each of these. Okay, today we're going to give you some examples of this. Let's talk first about the commutative property. Remember, this is the order doesn't matter. So I can say 2 plus 3i plus 3 plus 4i should be equal to 3 plus 4i plus 2 plus 3i. And with complex numbers, what we're really doing is just changing, or we're just combining like terms. So 2 and 3 are like terms, and 3i and 4i are like terms. So that gives me 5 plus 7i. And adding them in a different order does not change their value. We still have 5 plus 7i. Okay? Now if I wanted to do an example of multiplication, I could do that as well. I'm going to erase this so we have some room. We could have 2 plus 3i times 3 plus 4i should equal 3 plus 4i times 2 plus 3i. Now, this really gets into more of the distributive property, because you have to use the distributive property to do this, because we need to FOIL these out. So 2 times 3 is 6, 2 times 4i is 8i, 3i times 3 is 9i, and 3i times 4i is 12i squared. Now we can combine like terms, so we get 6 plus 17i plus 12i squared. Now remember though, I squared equals -1. So this really becomes -12. So 6 plus 17i minus 12. And that's going to equal -6 plus 17i. Okay? And on the other side, we're just going to do the same thing. We'll come up with 6 plus 9i plus 8i plus 12i squared, which we've already simplified, so we know that's going to be -6 plus 17i. And we have shown an example of the commutative property of multiplication. The associative property of multiplication applies as well, for addition and multiplication applies as well. A multiplication example would be a little bit more than we want to tackle right now. Not that it's not doable. It's just not something you're going to often see, so I'm not going to show it. But I will show you a short example of the associative property. So say we have 2 plus 3i added to the sum of 3 plus 4i plus 5 plus 6i. That should be equal to the sum of 2 plus 3i plus 3 plus 4i added to 5 plus 6i. And we'll do the stuff in the brackets first. So 3 plus 5 gives me 8. 4i plus 6i is 10i. And that's going to be added to 2 plus 3i. So that gives me 10 plus 13i. Adding on the other side, the 2 plus 3i and the 3 plus 4i, we get 5 plus 7i added to our 5 plus 6i. And we see that is 10 plus 13i again. And so there's an example of our associative property at work. Now our distributive property we have already covered with our example for the commutative property because we needed that property to work in conjunction with our commutative property to show that example. Let's do some more math, and this is probably way easier than what I just did. So you can see the easy parts of things if the last page was a little bit confusing for you. Okay? So 2 plus 3i added to 4 plus 2i. Again, we just combine like terms, but we're adding. There's a plus sign in the middle here. This is the toughest part for people. When they see two sets of parentheses, they automatically want to FOIL things out. But if there's a plus or a minus, we're just combining like terms. So 2 plus 4 is 6, and 3 plus 2i is 5i. For this one over here, we have 2 minus I over minus 2 plus 2i. So we need to distribute our negative to these terms. So we have 2 minus I minus 2 minus 2i. And combining like terms, we get 0 minus 3i. Now let's also do a couple examples using distribution. Here we have 2 plus 3i times 4 plus 2i. Now, there's no plus or minus in the middle, so we are going to FOIL these out. So 2 times 4 is 8. 2 times 2i is 4i. 3i times 4 is 12i. And 3i times 2i is 6i squared. Combining like terms, we get 8 plus 16i plus, and remember I squared is negative 1. So 6 times negative 1 is negative 6. And 8 minus 6, combining terms again, is 2 plus 16i. Okay? Here we have another one. 2 minus I times 2 plus 2i. 2 times 2 is 4. 2 times 2i is 4i. Negative I times 2 is negative 2i. Negative I times 2i is negative 2i squared. And we'll have 4 plus 2i. And remember, I squared is negative 1. So negative 2 times negative 1 is positive 2. And 4 plus 2 becomes 6. Bring down our 2i. So multiplying these together gives me 6 plus 2i. And I hope this helps. Most of the problems are not that much more difficult than that. So you should be able to do these fairly easily. We'll see you in class.